go. So what happens with the sun is the sun sends out its rays of radiation, which heat up the Earth. When they hit at the equator, they're coming through a small amount of atmosphere and also covering a small surface area, and so there's a lot of heating going on the surface of the Earth, which in turn heats up the air around the surface of the Earth. And what do we have when we have warm air? Well, the warm air rises. And so we're left with a low pressure on the surface of the Earth there. What happens to these air masses? Well, they reach the top of the atmosphere and there's nowhere to go but outwards. And so eventually they cool and they fall back down to the surface of the Earth, which in turn creates a high pressure as we have that air mass pushing down on the centre, and there's nowhere for it to go but outwards. And so what happens here is we have the airflow flowing from the high pressure down and into the low pressure. So that's kind of what happens initially to create this around the tropics, and that is known as the Hadley cell that this creates. The Hadley cell. However, further up at the poles, so we've still got the sun's radiation rays coming in. However, the amount of rays is trying to warm up a much larger surface area, and also a lot of it is missed as it just passes straight through the atmosphere and doesn't actually touch the surface of the Earth, which means the Earth's surface at the poles stays cold. Also, if you think about it, there's the colour of the surface of the Earth at that point is white, so there's a lot of reflection going on as well, which creates a very cold air mass around the poles, and so we have a falling air mass over the poles, giving us our polar high here, as opposed to this is a subtropical high, an equatorial low, and this polar high. So again, as the air mass comes down, it has got nowhere to go but outwards, and so we got this cool air pushes down from the poles, while we've got this warm air pushing up from the tropics, and where our warm air and cold air meets, it creates a bit of a battle zone, and that is the formation of our polar low. And so the air rises back up, again reaches the upper atmosphere, and there's nowhere to go but outwards. And so what happens here is we have the completion of our main air circulation cells, our main air distribution cells. The most furthest north cell is our polar cell, and our cell that kind of links the polar and the tropical Hadley cell is the Ferrel cell. This region here, as I say, is the polar low, and that's the most kind of fearsome bit of weather, as we have this massive change in temperature between the air masses, and it's the rotation of the Earth that forces this into a spinning low pressure depression, and it then tracks its way across the surface of the Earth. What's happening with the winds though across the surface? They don't just flow due south and due north from the highs to the lows, to do with the Coriolis force of the Earth. Anything that tries to travel south gets pushed to the west. So that means that as the winds try to go from the high to the low, they're getting pushed to the west. So they're creating these easterly winds, or east-northeast. These are our standard tropical trade winds. In the next kind of cell up, the winds is trying to go north towards the pole, and in this case it gets pushed towards the east. So we end up with these prevailing westerlies, and once again coming south from the high into a low is getting pushed to the west, and we end up with these polar easterlies, and they will all join up and circulate round our clockwise high pressures and anti-clockwise low and a clockwise high. So all we're doing is linking up these different systems here. This area in here ends up being what's known as the intertropical convergence zone, the ITCZ. And the reason for that is, in the southern hemisphere, as we complete the Hadley cell in the southern hemisphere, we have these winds trying to come from the high to the low. Again, because they're coming towards the equator, they're getting pushed to the west, and so we end up with these east-south easterlies. And so we don't have a full cog system completing here, so we just have this kind of band in between it. We just get this kind of low pressure band across the equator, full of thunderstorms and rising warm air, full of moisture. And that is how the circulation and the winds are created around the planet, really.